NASU rule, no? So what is NASU rule? That is a rule that will help us to draw the molecules, no? So we use NASU rule to draw molecules, no? So ano yung NASU? N is the needed electrons, so that refers to the number of electrons needed for an atom to achieve stability, no? So that is commonly referred to as the octet rule, no? So usually 8 yung electrons na kailangan. Why? Because the atom has to fill up the s and the p orbital. So pwede siya maging noble gas configuration. Okay, so yun yung needed electrons. That's usually 8, no? Except for hydrogen, which is 2. Okay? And the next one, available electrons. Available electrons pertain to the valence electrons. Depending on your group number, you have a certain number for your available electrons, no? Or your valence electrons. Next one is the shared electrons. So shared electrons, these are electrons that are used to form chemical bonds. And if two electrons are shared, we can have one chemical bond. No? So, for each chemical bond, dalawang electrons yung ginagamit. Okay? So, for you to determine how much electron must be shared, you must subtract needed and the available electrons. So, n minus a will give you the value for S. And then last one will be unshared. So unshared electrons, these are the electrons that are not used in chemical bonding. Okay? So sila yung lone pairs na tinatawag. So these are electrons that are unreactive and they do not react with other species. No? So to determine how much unshared electrons you have, the formula is A minus S. So that's available minus the shared electrons. And that will give you the unshared electrons. Just divide it by 2. So you will determine how many lone pairs you have for your molecule. Okay? So yan, ginamit natin yung NASU rule in order to draw lots of molecules here. Okay? So, yan. And then, suppose meron tayong combination, or I mean, possible combinations ng drawing. Ano ginagawa natin? Kunwari, I have multiple versions of my molecule that fits sa NASU rule. Ano gagawin natin? We determine the formal charge. So the formal charge is the charge of an atom if it is to be isolated from the molecule. Okay, so yan. So that is the charge of the atom when it is being isolated from the rest of the molecule. And the formula for formal charge is should minus half. No? Okay. So depending on the formal charge, you can either reject the molecule or pwede i-accept mo siya as the standard illustration for your molecule. So ito lang yung dalawang rules. Formal charges must be near zero. If zero yan, it is mostly preferred. No? And next one, depending on the type of the atom, it could have a preferred charge. No? So, kunwari, electronegative atom siya, then, kunwari, mataas yung electronegativity niya, then, ano yan, kailangan yan ay negative in terms of formal charge. No? Ayaw niyan masyado maging positive. No? Kapag mababa ang kanyang electronegativity, as much as possible, siya yung may positive charge instead of the negative charge. So, yun yung ginawa natin dito last time. So, the reason why we rejected molecule B compared to A is that for letter B, oxygen, which is electronegative atom, bears a positive sign dito. So, ayaw niya yon kasi electronegative yan eh. As much as possible, it must be positive 1. Okay? So, yan. Yun. So, yun yung isang reason why we rejected molecule B instead of A. Kasi yung oxygen, positive 1. And also, yung A, better talaga to kaysa sa B. Kasi sabi natin, as much as possible, formal charges must be 0. Especially if the molecule is uncharged, no? Hindi siya ionic compound, okay? So kapag walang charge yung molecule, as much as possible, 0 yung mga formal charges, okay? So, sa mga wala last time, magpa-practice tayo ulit na. So, before we continue with the main topic for today. Okay, so let's continue. Let's recall pala. Okay, so let's try to answer number 1 only. So, write the possible arrangements and the most likely Lewis structure for formaldehyde, CH2O. So, formaldehyde is used as pang-embalm, no? Pang-embalming yan eh. Okay, so yan yung ginagamit sa mga patay-patay, no? Okay. So let's try to determine ano kaya yung magiging structure niyan. So let us use the NASU rule first. So NASU, C, H, and O. Okay. So needed electrons. Carbon, it requires 8 electrons because it follows the octet rule. Sir, paano ko po malalaman kapag magpo-follow yan ng octet rule? If your atom contains p orbital, then octet rule dapat yan. Okay? So carbon is in the p block of the periodic table. Hence, it must follow the octet rule. So we must have 8 needed electrons for carbon for it to be stable. Okay? So how about hydrogen? So since hydrogen doesn't have the p orbital, so it can only fill up its s orbital. Hanggang dun lang siya sa s orbital. So 2 electrons lang yon. Times 2 since we have two hydrogens here. Oxygen, this is also in the p block, so that will be 8 electrons. So needed will be 8 plus 8, 16 plus 2 times 2, 4. So that will be 20 electrons. Okay, so we have 20 needed electrons there. How about available? So as I told you earlier, available pertains to the electrons that are equivalent to its valence electrons now. So for carbon, it has 4 valence electrons because it is in group 4. Hydrogen, 1 valence electron kasi nasa group 1 siya. And then oxygen, 6 valence electron times 2 pala yung hydrogen, sorry. Okay, so 6 valence electrons for oxygen kasi nasa group 6 siya. So let's add all this number, 4 plus 2 plus 6, so that will be 6 plus 6 or 12 electrons. Okay, for S, that is N minus A. So that's the formula that we're going to use. That is 20 minus 12 equals 8 electrons, or how many bonds can we form from 8 electrons? We can form 4 bonds, okay? And then lastly, for unshared electrons, that is A minus S. That will be 12 minus 8. 12 minus 8, that's 4 electrons. Or how many lone pairs? That will be 2 lone pairs. No? So, dalawang lone pair yan. Okay? Kaya nga pair, tigda dalawa. Okay? Okay, so let's try to draw. Ano ba yung mga possible structures for formaldehyde? Okay? So, pwede gawin natin, i-identify muna natin which of the atoms ang least electronegative with exception to hydrogen. Okay, why hydrogen? But exempted siya kasi we know that hydrogen is the terminal atom as always, no? So yung terminal atom, siya yung kumakabit sa central, no? The reason why hydrogen cannot be the central atom is that it can only form one bond. Okay, so isang bond lang kaya niya gawin eh. Compare that to carbon which can form 4 bonds, no? So, yan. Ganun gagawin natin. So, we determine first which of the atoms will be the central and the terminal atoms, no? So, obviously, si hydrogen, terminal yan. So, we're left with carbon and oxygen. Least electronegative atom dapat ng central. So, that will be carbon. So, carbon will be our central atom. And that means oxygen and hydrogen will be our terminal atoms. So we can draw several illustrations or several arrangement ng atom sa molecule ng formaldehyde, no? Basta ang nasa gitna ay carbon. So, pwede gawin ko HCOH. Okay, pwede ganyan. Ano pa kaya pwede? Pwede rin naman ganito na lang. Okay, so yan. So, ito yung two possible arrangements ko. I have HCOH in linear form, and then I have HCO, then H sa taas. Okay? So, let's determine sino sa dalawang yan ang most likely Lewis structure for this molecule. So, ano ginagawa natin dito last time? You draw the bonds. No? So, you draw the bonds. So, we have 4 bonds. So, for molecule A, yan. So, connect natin yung atoms. 1, 2, 3. Saan mo ilalagay yung sobra? Kahit saan, except for bonds with hydrogen. Okay? Bakit hindi pwede sa bonds with hydrogen? Kasi hydrogen can only form single bonds because of the s orbital only yung meron siya. Okay? So, that will be the structure for letter A. For letter B, draw natin yung connection. Again, yung bonds to hydrogen, single line lang yan. Okay, so we will have this illustration. Ayan, nabigay na natin yung 4 na bonds to each molecules. No? Paano naman yung lone pairs? No? When distributing lone pair, you check first kung octet na yung terminal atoms. Kasi kapag hindi siya octet, then you can apply the lone pairs para makumpleto yung octet niya. Okay? So, kapag kumpleto na yung octet ng terminal atoms because of the lone pairs, dun ka magbibigay sa central lastly. Okay? So, let's try that for letter A. O, yung hydrogen, check mo. Okay na ba yung dalawang electrons na needed niya? Yes, no? Kasi as long as may isang line ka nakikita, 2 electrons katumbas nun. Okay? So that means for hydrogens, satisfied na yung 2 electrons necessary for it to be stable. How about the oxygen? So this is one of our terminal atoms. So this oxygen has 3 lines or 3 bonds around it. So that means it already has 6 electrons. So for it to be octet, we have to add lone pairs. No? Maglagay tayo ng isang lone pair. Maglagay tayo ng pares ng electron. So is it octet now? Okay, so it is octet now. Okay, so we have 1, 2, 3. 3 bonds yan times 2 electrons. So 6 electrons yan in total. Plus the 2 lone pairs. No? I mean the lone pair. Okay, so 6 plus 2 is 8. No? So octet na yung oxygen. How about the carbon? May sobra pa tayong lone pair na isa eh. So carbon, it doesn't follow the octet rule. So we have to add lone pairs din kay carbon para maging octet siya. Okay? So yan, nagamit na natin yung 4 bonds, 1, 2, 3, 4, and yung dalawang lone pairs, 1, 2. So this seems to be plausible. No? Mukhang okay naman tong structure na to. But we have a contender. No? Meron tayong katunggali yung molecule na yan. So we have letter B. So for letter B, let's check hydrogens if satisfied na yung 2 electrons. Satisfied na yan. Okay. Let's check the terminal atoms. So for the terminal atoms, how many electrons are there already? We have 4 electrons. Now, because we have 2 bonds times 2 electrons, 4 electrons yon. Ilan pa kulang? 4. No? Pwede mo ilagay yung 4 na electron in the form of 2 lone pairs. No? So, lagay mo yung lone pairs dyan. And, yan. Nagamit mo na yung lone pair. Well, you check the central atom. Does it follow the octet rule? So, it seems that it follows the octet rule because we have 4 bonds around it. So, 4 bonds times 2 electrons each bond, you have 8 electrons in total. Okay? So, it seems that A and B are okay naman. No? So, ano magiging decision natin dito? We check the formal charges. Okay? So, the equation for formal charge is should minus have. Okay, so when we say should, this pertains to the valence electrons. When we say have, that pertains to the number of electrons around the atom. Okay, so before we determine yung formal charge, ano ginagawa natin? We draw imaginary boxes so that we can isolate the atom from the rest of the molecule. Okay, so the purpose of drawing imaginary boxes is to divide the electrons sa bonds, no? So para mahati yung electrons sa isang chemical bond. Okay, so let us draw imaginary boxes, cutting the ano, cutting the chemical bonds. No, ayan. Okay, so ganito na lang. Ayan. So ayan, so kinat ko na yung chemical bonds. What's the purpose? For us to see or to visualize na kapag sinabi nating isolate the atom, ibig sabihin nun, we have to cut the bonds, no? So, yung two electrons doon, may split yan into each ends, no? For example, yung dalawang electrons dito, yung isa mapupunta kay hydrogen, yung isa mapupunta kay carbon. So, that's the purpose of isolating electrons or cutting the bonds, no? Para malaman natin yung have electrons natin. Okay, so let's determine the formal charges of the atom for each illustration ng molecule, for each structure. Okay, for hydrogen, should is 1. Should kasi isa lang valence electron niya. Have ilan? Isa lang, no? So, isang electron lang dito, yun na kay hydrogen, no? Again, remember, hinati natin yung bond. Di ba dalawa electrons diyan? Pag hinati mo yon, yung isa mapupunta dito, yung isa mapupunta sa kabila. So that means isa na lang yung natira kay hydrogen. So that is 1 minus 1. 1 valence electron minus 1 half electron. Okay, so 1 minus 1 is 0. So wala siyang formal charge. Let's have carbon. Okay, so this carbon should is 4. Okay, so should is 4. 4 valence electrons yan. Have is how many? Bilangin natin. So we have 1, 2, 3, 4, 5. So we have 5 electrons around the carbon when you cut the bonds, no? So that will be 5. 4 minus 5 is negative 1. Okay? Now, medyo red flag na yan pag ganyan. Bakit siya red flag? Kasi carbon is the least electronegative atom. So that means it must not have the negative charge. Okay? So medyo red flag pa lang yan. Okay? Tignan pa natin yung ibang atoms. So how about oxygen? So should is 6. Kasi group 6 yan. Have, bilangin natin. We have 1, 2, 3, 4, 5. So we have 5 electrons around oxygen when it is isolated. 6 minus 5 is positive 1. O, another red flag. Okay. Ano kaya zodiac sign yan? Okay. So yan. So ito ay red flag uli kasi positive yung charge niya, and we know that oxygen is the most electronegative atom in this molecule. Okay? So, dalawang flags na meron siya. How about hydrogen? So, hydrogen, that's 1 minus 1 pa rin or 0. Okay? So, that's the formal charges of each atom for letter A. How about letter B? Okay? So, for hydrogen, okay, bilisan na natin. So, 1 yung valence electrons nila. How many nasa paligid nila? Isa din. So, when we cut the bonds, yung isa mapupunta dito, yung isa mapupunta kay carbon. Ganon din dito. Isa mapupunta dito, isa kay carbon. So, may tig-isang hydrogen sila when the atom is isolated. Okay? So, 1 minus 1 is obviously 0. So, we do not have formal charges for hydrogen. Okay? And then, for carbon, should minus have. So, should for carbon is 4. Have is apat din. No? So, 4 minus 4 is 0. So, we do not have formal charge for carbon. And for oxygen, should is 6. 6 valence electrons yan. And then how many half electrons meron tayo when the atom is isolated? We also have 6 now. 1, 2, 3, 4, 5, 6. Okay, so 6 minus 6 will be 0. So of the two illustrations, we saw that letter B is the most it is the most likely structure for the formaldehyde instead of letter A. No. Why? Number one, sabi ko kanina, ang basis natin is that as much as possible, the formal charges must be near zero or at least zero at all. Okay? So letter B yung nagko-qualify doon. Number two, yung electronegative atoms, sila yung negative dapat. Na-violate na yun ni letter A. And yung least electronegative atom, yun yung positive dapat, which is also violated by structure A. So that means letter B is the final structure for formaldehyde. Okay? So ganun lang. So yun. So the NASU rule works, hindi. Akala ko proceed na ako sa next part. May resonance pa pala tayo. So what is resonance pala? Punta tayo sa resonance. So when you say resonance, it pertains to the flow of electrons around the bonds in your atom. So let's have an example, carbonate ion. So this is the lowest structure of carbonate ion. Let me draw it here. No? So this is the structure of carbonate ion. The oxygens that are singly bonded to carbon has a -1 formal charge. Okay? So the overall charge of the ion is -2. Okay? So yan yung ating carbonate ion. Is there another possible way to illustrate this molecule? Okay. So pwede meron pa siyang isang illustration. Ano 'yon? Ang isa pa niyang illustration is that instead of the double bond being on the top part, pwede siya yung nasa left side. Okay? Pwedeng ganito yung illustration niya. Okay? So pwede ganyan yung illustration ng ating molecule. What else? Pwede rin naman na yung ating electrons ay yung ating double bond mapunta sa right side. Okay? So pwede mapunta siya doon sa right side. So, ano yung purpose nitong resonance? Ang purpose ng resonance is ganito. Okay. So it tells us how many similar structures can we create out of the molecule na by just moving the electrons around. Pansinin nyo, di ba yung double bond andito. What if the electron moves from this bond to this bond, let's say, no? What if yung electrons mapunta dito? Ganitong structure yung magagawa natin. Instead na dito mo ilagay yung double bond, dito mo nilagay. So this molecule is similar with this one. Kunwari naman, yung double bond nilagay mo dito, ito yung magiging itsura ng structure mo, no? As you can see, these three are equivalent structures. Ano lang pinagkaiba? Yung position of the double bonds, no? Whenever we have similar structures but we have whenever we have the same structure, similar structure, pero yung position ng double bonds ay iba-iba, that's resonance, no? So again, paano mo malalaman kapag resonance? You have similar structure, pero yung position ng double bond, it rotates around the central atom. Okay? So it rotates around the central atom lang. Pwede yun dyan, pwedeng dito, pwedeng andon. No? So ganun. So yun lang. So how will you determine how many resonance structure can you create? No? So para malaman mo how many resonance structure you can create, no? It's your task, no, to shift the positions of the double bonds, no. So ikaw na manually magmo-move ng electrons. Check mo ano yung mga possible structure by shifting the position of the double bonds to the other atoms dito. Okay? So yan. Whenever a molecule exhibits resonance, no, it possesses a special characteristic, no. That characteristic is the stability of the ion or stability of the molecule itself, no. So yan. So whenever our molecule can do resonance, that means it can also be it can also be stable, no. So hindi agad-agad siya reactive. So stable yung mga molecules that exhibit resonance. One example of which is benzene ring. Okay? Sa organic part natin, we will see kung sino si benzene. Pero sa ngayon, ito yung itsura niya. So this is a benzene ring. Tawag nila dito ay piatos kasi hexagon yan. So organic chem pa to. Okay. So si benzene ring, this is a hexagon. Okay. So molecule yan. Malalaman nyo yung meaning ng structure na yan sa dulo ng SEM. Okay. So isa siyang hexagon wherein the double bonds are alternating. So that means may double bond dito, wala doon, double bond dito, wala doon, double bond dito, wala doon. Okay? So ito yung isang structure for benzene. Okay? Another structure is when your double bonds shift one position to the left or to the right. No? So suppose this double bond moves here. So kapag nag-move yung double bond there, all the other double bonds will follow. No? So ganun. Okay? So kapag nag-move yung itong double bond dito, papunta dito, yung iba susunod din. Okay? So bakit sila sumusunod? Ang sagot doon is Lewis structure. Kasi kapag ito, nilagyan ko ng double bond dyan, lalagpas na to sa octet rule. So that means it has to push the other double bonds also sa other side. No? So that means kapag gumalaw to dito, yung iba lilipat doon. So the rotation of the double bonds, no, is possible around the structure. So ito rin yung reason why benzene is stable, no. Sa organic chemistry, benzene is one of the molecules that is very selective to the chemicals that it reacts with, no. So masyado siyang choosy kung kanino siya magre-react, no. So yun. Ang reason kung bakit ganun is resonance, no. Iba-iba kasi yung mga possible structures ng benzene, okay? So yan. So similar structures pero the position of the double bonds are different, no. So whenever that's possible, you have a resonance, no. Okay. Ano uli importance ng resonance? Stable sila, no. So mga molecules na may resonance, they possess special stability. Hindi agad-agad sila nasisira, hindi agad-agad sila reactive, no. So yan. So yan. Okay, so let's now proceed with ito, sagutan natin. Let's draw the resonance structure of the molecule N2O, nitrous oxide. So, ano yung gagawin mo muna? NASU rule. Okay? So, let's do the NASU rule. Nitrogen, oxygen. Needed, nitrogen and oxygen are in the P block. So, that means 8 electrons each. That will be 8, 16, 24 electrons. Available, nitrogen is in group 5 times 2 because we have 2 nitrogen atoms here. And then oxygen, group 6 yan. Okay. So ano yan? Group 6 yan. So 5 times 2, 10 plus 6 is 16 now. So S shared, that is N minus A. So that will be 24 minus 16. Ilan yan? So that is 8, no? 8 electrons yan or 4 bonds. Okay. And then U, unshared. So unshared, that will be 16 minus 8. Okay. So ilan yan? 8 na. Or 4 lone pairs. Okay. So ito yung info natin from the NASA rule. So we can use all these numbers in order to determine what will be the structure for nitrous oxide. And di isa lang yung itsura ng molecule na magagawa natin dito. NNO lang. Okay? No. Para siyang no. Okay? Hindi pwedeng non. Okay? Hindi pwedeng non kasi if non yung gagawin nyo, oxygen will be the central atom. Remember, oxygen is terminal atom as always, no? So, hindi pwede yan. So, NNO lang yung possible na configuration natin dito. So, let us draw the 4 bonds. 1, 2, 3, 4. Okay? So, pwede ganyan. So, pwede rin naman ganito. Okay? So, pwedeng andito yung triple bond. Okay? Saan pa pwede? Tignan natin. So, lagyan natin yung triple bond between nitrogen and oxygen. Okay? So, yan yung mga possible configurations natin. No? Okay? How about the lone pairs? So, for the lone pairs, distribute natin yung ating electrons. Terminal first. So, oxygen muna. No? So, oxygen, 4 electrons yan. So, let's add the lone pairs. So, 4 dapat. Okay, so octet na yan. We added 2 lone pairs para maging 8 na yung electrons around oxygen. For this terminal atom, ganun din. No? So, 4 electrons meron yan. So, gagawin natin yung 8 by adding the 2 lone pairs. And the central atom follows the octet na. Okay, so we're good with the central atom. How about itong nasa baba? So, for the molecule here below, ito ay oxygen muna. May 2 electrons na dyan. Okay, so dito sa oxygen, 2 electrons yan. So, kailangan niya pa ng 3 lone pairs para maging octet. For the nitrogen here sa left, 6 na electron yan. So, it requires one more lone pair. Okay. And then on the center, octet na yan. So, octet na yan. So, about itong nasa baba. Okay. So, itong oxygen muna. So, isang lone pair dyan. Okay. So, dito sa left, lone pair natin will be 3 for the nitrogen para ito ay maging stable. And then, nawala yung central atom. Okay, so yung central atom, it is already stable na because it has 8 electrons around it or 4 chemical bonds around it. Okay, so yan. Hindi pa tayo tapos actually. We determine sino sa tatlong yan yung plausible structures. Okay. So ako, by just looking, I say that this one will be eliminated. Okay? So itong nasa baba, may eliminate yan. Why? Because the formal charge of oxygen here will be +1. For the molecule here, we have -1 and then 0. So I want you, kayo na lang gumawa niyan after the class. No? Mini-mental ko na lang yung formal charges. So mapapansin nyo, sa third drawing natin that oxygen will bear a +1 charge. So, hindi siya qualified. Okay yung -1, okay yung 0. Okay? Pero yung +1, no. So, no yan. How about the 2 other atoms? Okay? So, for nitrogen, this will be +1. And this will be 1, 2, 3, 4, 5, 6, -1. So, dito naman sa second molecule natin, this will be +1 and that will be 0. Okay? So, ito, hindi talaga to pwede. Okay? So, the third structure is not okay. Pero, yung first two, ito pwede pa to. Baka isipin nyo, sir, yung nitrogen dito, -1. Okay? So, okay lang din naman. No? Kapag resonance kasi nag-switch lang yung position ng position ng charges eh. Okay. So okay lang may negative tayo kay nitrogen as long as yung oxygen never siya magiging positive. Okay. Yung mga electronegative atom talaga kasi yung basis kapag magche-check tayo ng formal charges, no? So si nitrogen, forgivable pa yan. Magkatabi kasi sila sa periodic table, nitrogen, oxygen. So pwede pa siya maging negative. However, oxygen must never be positive, no? So that means these are the two resonance structures for N2O. No? So yun, the one with oxygen with zero charge and the one with oxygen with -1 charge. Never this one kasi positive charge siya. Okay? So yan. So yan yung resonance structure niya. So pwede ganyan, pwedeng ganito. So you can see the electrons are just moving, no? Gumagalaw lang siya sa ating atom. Pwedeng andito siya in between nitrogen oxygen, so may double bond doon. Pwede naman andito siya between nitrogen and nitrogen. So you have the triple bond there. Okay? So ganun yung ating way to determine the resonance structures. Okay? So yan. Ngayon, let's go with the next topic, expansions, exceptions to the octet rule. So as you can see, our discussion is limited with the atoms that are in the second period sa periodic table. So when I say second period, yun yung mga boron, carbon, nitrogen, oxygen, fluorine. Hanggang dun lang tayo, di ba? How about the atoms below it, no? Can they be central atoms, no? Pwede ba sila maging terminal atom? Yes, pwede maging terminal atom. Pero can they be central atom? Pwede rin, okay? Pero ito yung thing with the atoms below, starting from third period below sa periodic table. Okay, so when I say third period below, buksan natin yung ating periodic table. So when I say third period below, I refer to these atoms here. Okay, so itong atoms starting from aluminum pababa. Okay. So pwede din sila maging central atom. Kaso nga lang, ang problem is ganito. What do we know about the atoms in the third period? Ano meron sila? 'Di ba kapag first period s orbital lang. Pag second period we have the s and the p orbital kaya octet rule 'yon. How about the atoms in the third period pababa? They have the d orbital and the f orbital. So that means they require more electrons, no, for them to be stable. Okay? So they will need more electrons for them to be stable. So they may violate the octet rule. Okay? So yun yung expanded octet, no. Kapag yung atom natin, they can contain more electrons than the 8 electrons. Okay? Bakit may expanded octet? Kasi lalagpas ka sa 8 electrons due to the presence of d orbitals, no. Okay, so the d orbital can hold 10 electrons kasi. So 10 electron plus 8, no? A maximum of 18 electrons yun in total. Okay? So yun, pwede tayo lumagpas sa octet rule provided that your atom, especially your central atom, is on the third period pababa. Okay? Ayan, lobat ako. Okay, so what else? No? Other than the expanded octet, we have the other two, the incomplete octet and the odd electron molecules. Okay? So for incomplete octet, this is usually true for atoms of second group and third group, no? Yung mga beryllium, magnesium, calcium, boron, aluminum, no? Sila yung nagfa-follow ng incomplete octet. Okay? So yan. So usually there are the atoms in the second and then the third group, no? Okay? So sila yung incomplete octet. Okay, so mamaya habang nagdo-drawing tayo, explain natin. And then we have the odd electron molecules. This applies for group 5 atoms, especially nitrogen. Okay, so yan. Group 1, group 2 for incomplete octet. Group 5 for odd electrons. And the expanded octet is from third period below. Okay, so when I say third period pababa, it starts from aluminum all the way down to baba. Okay, so nasa baba. Okay, so let's check, no? Paano yung incomplete octet? So incomplete octet happens when your central atom is in, group 2, group 3 pala to, sorry. So when your central atom is in group 2 and group 3, no? So for example, let's have beryllium hydride. Okay? So BH2, si Be, no? So tignan natin if Nasurul will work dito. Kasi this molecule is proven to exist. Pero tignan natin if Nasurul will work dito. Suppose beryllium, will it follow the octet rule? Okay, so will it follow the octet rule? Pwede, no? So sige, gawin nating 8. Try lang. 8. About hydrogen, dalawa lang talaga yan. So 8, ayan, 8 plus 2 times 2 is 4. So that will be 8 plus 4 is 12. Okay. About the available electrons. Beryllium, 2 available electrons yan. Hydrogen, 1 lang. Okay. So that's 2 plus 2 equals 4. So shared will be 12 minus 4. That will be 8 electrons or 4 bonds. Okay. Dito pa lang, sa part pa lang na ito, may problem na ako. Ano yon? If I draw my beryllium hydride, syempre, yung hydrogen terminal yan. Sabi ko yun last time. So, hindi mo kaya yung 4 bonds. Bakit? Kasi, hydrogen can only perform single bonds. Isa lang bond na kaya niya gawin. Paano yung sobra na 4? Okay, so that means yung Nasu rule will not apply for this molecule, no? Yung mga incomplete octet. So, hindi gagana yung Nasu rule dito. So, sir, paano ko gagawin yan? Paano ko yan i-draw? Okay, so kung para i-draw mo yan, you basically, yung connect the dots na ginagawa nyo noong high school. So, yun na yung pinaka-simplest way. Okay, so gawin nyo na lang yung connect the dots, pero again, be mindful kung sino yung terminal, sino yung central. We know that beryllium has 2 valence electrons, hydrogen have only 1, no? So pwede mo sila pagdugtungin na lang. Okay, so kahit di ka na mag-Nasu rule kapag incomplete octet. Okay, so ganoon na lang, connect the dots. So kapag tignan mo, pag nag-Nasu rule ka, may complication agad. Okay, so may problem agad tayo eh. So again, if your central atom is in the group 2 or group 3, wag na kayong mag-Nasu rule. Mag-ano na lang kayo, connect the dots. Okay? For example, aluminum hydride, no? ALH. Wag na hydride, aluminum chloride, let's say. AlCl3. Try natin Nasu dito. So, nitrogen, yan ay nasa group 3. Chlorine, nasa group 7. Ay, needed pala yan, sorry. Needed, 8. Tapos ito, 8 times 3. So, that will be 8, 16, 24, 32 electrons. How about the available? Aluminum is in group 3. Okay. And chlorine is in group 7 times 3. So, that will be 7, 14, 21, 24. Okay. 32 minus 24. Ilan yan? That will be 8 or 4 bonds. No? 4 bonds yan. And then U unshared will be 24 minus 8 is 16 or 8 lone pairs. No? Okay, so medyo matatagalan pa ako dito pero kagaya nga ng sabi ko, Pag ang iyong central atom ay group 2, group 3, wag na kayo mag-NASA rule kasi matatagalan kayo. Gaya ng ginawa ko. Tatagalan pa ako mag-drawing dito. So, let me try. Okay? So, aluminum, Cl, Cl, Cl. Okay? So, may 4 na bonds daw, no? 1, 2, 3. Saan mo ilalagay yung pang-4 na bond, no? Ang problem is ganito kasi. Like hydrogen, yung mga group 7 atom, they usually perform single bonds lang kapag sila yung terminal atom. Okay? So usually, yung group 7, kapag sila yung terminal atom, they can only do single bonds, no? Pero kapag ginawa mo yung double bond, mahirapan ka maglagay ng lone pairs, no? So tignan nyo. No, chlorine. Chlorine, so may 2 electrons na yan. So naglalagay ako ng 3 lone pairs. Octet na yan. So 5 pa yung natitira. So about this one, ito ay chlorine. Ayan ay may 4. So 4 pa na electrons kailangan. So minus 2, 3. Ayan, sobrang 3 dito. Okay. So mukhang okay yung lone pairs, no? Pero pag tinignan mo yung formal charges nila, doon kayo magkaka-problem. Especially kay chlorine. Okay. So si chlorine na yung focus ko. Kasi alam ko kung saan banda may mali eh. So si chlorine, kung mapapansin nyo, pag kukunin yung formal charge niyan, should minus have. Should is 7, have is ilan? 6, that is equal to positive 1. So this chlorine atom will bear a positive 1 charge, no? And aluminum, ang should minus have nito ay 3 minus 4, okay? So 3 yung valence electron niya, 4 electrons nakapaligid sa kanya. So 3 minus 4 is positive 1. I mean negative 1 pala, sorry. So negative 1. So mali agad yung structure. Okay, so umpisa pa lang mali na. So in order for us to resolve this issue, wag na kayo mag-NASA rule kapag ang central atom ay group 2 and group 3. Ano na lang gagawin nyo? Yung simple connect the dots na ginagawa nyo nung high school. So you draw aluminum with its 3 valence electrons, the chlorine with its 7 valence electrons. Okay, so you draw their 7 valence electrons na lang. And then you connect them later on. Okay, so that will give you the final structure AlCl3. Okay, so yan yung final structure ng aluminum chloride. Okay, so yun na yun. It doesn't matter whether aluminum is octet or not. Kasi pag nasa group 2 and group 3, incomplete octet talaga yan. Okay, so ganun lang. So ano ulit gagawin nyo to determine whether that's incomplete octet or not? You check, sino sa dalawa yung magiging central atom ko? Okay, if my central atom is in group 2 or in group 3, then wag na akong magna-NASA rule. Okay, so i-X ko na yung NASA rule ko. So ano nang gagawin ko? Just connect the dots na lang. Okay, so draw the Lewis symbol, Lewis dot symbol, and then connect the single lines to form the chemical bonds. Okay. So yun yung first exemption. The second one is the odd electron molecules, no? So when we have odd electrons, dito nag-exist yung radicals, no? So siguro familiar kayo with the radicals, no? Kasi sa mga food supplements, sinasabi doon, it helps to remove radicals sa ating body. Okay, and totoo naman yun, yung mga food supplement, they really remove free radicals in our body. Kasi if we have radicals in our body, we will be vulnerable to diseases, no? Totoo yun. Okay. So kapag yung pagkain may radicals doon, mas mabilis siya mapanis, no? Yung tao kapag may radical, mas madali magkasakit, no? So ganun, totoo 'yun. So ganun din dito sa molecules natin. Okay? So ano ba yung radical, no? Remember, we have two types of electrons, no? We have lone pair, yung dalawang pares, And we have the single electron only. Yung single electron, that's called the radical. What's the problem with radical? Bakit nasisira yung pagkain agad? Or bakit tayo nagkakasakit agad dahil sa radical? The reason why medyo detrimental yung effect niya is that radicals are so reactive. No? Madikit lang yan sa isang molecule. Guguluhin na niya yon. Okay? So, madikit lang siya sa ibang molecules, maninira na siya ng ibang molecules. No? So, ganun siya ka-reactive. No? Especially yung single electron na yan. Kasi kapag bi-pair sila, chillax yung electron. Naka-chill siya. Pero kapag single lang yan, galit na galit yan. Okay? So, ganun. So, galit na galit yung electron na yan to a sense na it can form chemical reactions or it can do chemical reactions with the other atoms. No? So, yun yung problem with radicals. No? Kaya nga sinasabi, bawasan yung mga radicals sa ating katawan para hindi tayo magkasakit. Kasi kapag may radical tayo sa katawan, that single electron may disrupt our body's function. No? And then when our body function is disrupted, so that means may sakit tayo. Okay? So, totoo yung mga nasa commercial na yan. So, paano ko po ito-drawing yung odd electron molecules? Let me erase this part muna. Para lang tayo nag-whiteboard dito. No? Mas feel ko kasi kapag online class nagsusulat ako. Pares tayo mabagal magsulat. Okay? Okay, so yan, burado na. Okay, so paano ko po ito-drawing yung molecules that will fall under odd electron molecules? No? So, paano mo muna malalaman kung pwede yung odd electron molecules dito? Just take a look sa group number ng central atom mo, especially nitrogen. Nitrogen kasi madalas yung gumagawa nito ng radicals. Okay? So, yung gagawin mo, you determine whether the central atom is nitrogen or anything below it. No? Pag yun yung case, okay, so pwedeng magkaroon kayo ng radical or pwedeng usual calculation lang. Katulad ng ginagawa natin kanina. For example, ito sir, may nitrogen naman. Parang wala ka naman sinabi about radicals. Wala talaga. No? Okay. Bakit? Kasi ganito. Malalaman mo lang yan kapag radical yan when you solve for the Naso rule. Okay? So, gawin natin. Bigyan ko kayo example, itong NO2. Nitrogen dioxide, which is a radical that is present in the air, it causes acid rain. Okay? So, yan. NO2. Isa yan sa mga greenhouse gases. And cause ng acid rain. Okay? So, yan. NO2. Let's try to draw this. No? Tignan natin kung yan ay may radical or not. No? Paano? Ganito, start ka lang, Naso rule. Kunwari, wala ka pa rin alam sa group 5. Okay? So, kunwari, wala pa akong dinidiscuss about radicals. So, nitrogen, it will follow the octet rule. Oxygen will do the same. 8 times 2. So, that will be 8, 16, 24. Available, nitrogen ay 5. Oxygen ay 6 times 2. So, 6 times 2, 12, plus 5, 17. O, dito pa lang magtaka ka na. Bakit? If you are unaware, tignan nyo yung A ng ating mga molecules kanina. Ito, 17 to, odd number yan. Tignan mo yung A ng mga drawing natin kanina. Formaldehyde, A is 12, even number. Nitric acid, A is 24, even number. Carbon dioxide, A is 16, even number. Nawala na yung iba. Ito pala. CH4, A is 8, even number. NO+, may nitrogen yan, pero tignan mo, yung A ay even number. Kaya nag-proceed lang tayo, di ba? Carbonate, 24 yung A, no? So even number. And then NF3, Oh, sir, may nitrogen yan. Pero tignan mo yung A, even number. Okay? So, whenever your A is even number, that's okay. Okay lang yan. Proceed ka lang. Pero, kapag ang A mo ay odd number, then it will follow the odd electron molecule exemption. Okay? So, odd electron molecule yan pag ganun. Pag may pag may odd number ka sa A. So, ano po gagawin ko? Tuloy mo lang yung NASA rule. Just continue doing the NASA rule, okay? So, tuloy mo lang. Basta may idea ka na kapag odd number ito, exemption yun sa sa octet rule. Okay? Basta odd number yan, exemption agad yan sa octet rule. By the way, take note baka kulang kasi ng charge, no? Baka hindi mo manasabay yung mga charges. So, you include the charges muna before you can decide whether that's odd or not. Okay? In our case, wala tayong charge. So, 17 talaga yung available. Wala na tayong magagawa dyan. So, A is n minus A. So, that is 24 minus 17. That's 7 electrons. Ito pa. If you divide that by 2, yung 7, saan yan equal? 3.5 bonds. Possible ba yung 3.5 bonds? No. So, paano mo i-drawing yung kalahati lang, sir? Binitin mo ba, no? Walang ganun. Okay. So, hindi natin pwede gawin yung 3.5 bonds. No? Hindi pwede imputol yung bond. Okay? So, meaning nun, ganito, may radical tayo. Okay? So, ano po gagawin ko para malaman ko kung ilang bonds ba talaga kailangan? Okay? So, ganito po gagawin nyo. If you have odd numbers available, that means odd number yung lalabas sa shared. Okay? Then, para makuha ninyo yung radical, split nyo yan into 2. Magma-minus 1 ka for the radical, and then the remaining 6 electrons will be used sa bonds, no? Ito yung gagamitin mo sa bonds. You will have 3 bonds. Yung sobrang isa, yun yung radical. Okay? Isang radical lang madalas. Okay? Ay, ano uli gagawin ko? Kapag kapag yung A ko odd number, ang gagawin ko, yung S odd number din for sure pag kinalculate mo yan. So kapag odd number yan, for our example, 7, what you're going to do is to split that 7 into 2. Yung isa, 1, and yung natirang 6, yun yung gagamitin mo sa bonds. Yung isang hiniwalay mo, yun yung radical. Okay? So, yun. Split mo yan into 2. Yung isa radical, the remaining ay sa bonds. And then you continue. Okay? So, unshared is A minus S. So, that's 17 minus 7. That's 10 electrons or 5 lone pairs. Take note lang may radical na tayo this time. Let's draw NO2. Again, nitrogen will be the central atom. Oxygen will be the terminal atoms, and the structure is no. Okay, so yan. Oh no. Lagay mo na yung tatlong bonds, no? So ganito na lang. 1, 2, 3. Okay, so nalagay ko na yung tatlong bonds. Ano susunod? Yung lone pairs. Yung radical sa dulo na yan nilalagay. Okay? So lagay mo na yung lagay mo na yung lone pairs. Terminal muna. So this atom has 2 electrons. For it to be stable, kailangan ng 8. So I will give it 3 lone pairs. So may 2 na lang ako natitira. This atom has 4 electrons. So kailangan niya ng 2 lone pair. Ayan, nagamit ko na lahat ng lone pair. Okay? So ubos na yung 5 lone pairs ko. Last na gagawin mo is to place the radical. Saan ko po ilalagay yung radical? Sa central atom usually. Sa nitrogen. So kapag radical yan, single dot lang yan. Okay? So radical yan. And that will be the structure for NO2. Yan na yan. Okay? May tuldok lang siya sa nitrogen. Okay? So again, ano gagawin mo? Para malaman mo kung yan ay exemption sa octet rule, you check whether ang iyong available ay odd number. Okay? Pag odd number yan, that means odd number yung shared electrons mo. So, dun sa odd number, mag-minus 1 ka, yung isang yon magiging radical. The remaining electrons will be your bonds. Okay? So, you draw the skeleton, lagay mo yung bonds, lagay mo yung lone pairs, and then you place the radical at the end. Okay? So, ito, octet to. Ito, octet din to. Pero, ito, this is not octet. No? So, ilang electrons yan in total? 7 lang. But this molecule exists despite of it not following the octet rule. So kahit 7 lang yan, nag-exist yan. Okay lang. Okay? Kasi odd electron rule nga. Kaya nga sabi natin exemption sa octet rule. Okay na yan. No? Kahit ganyan yan. Because of the radical. We have no choice. But just to accept na ganyan talaga siya. And then last one, we have the expanded octet. So for the expanded octet, again, this applies for the atoms, for the central atoms that is third period below. So when I say third period below, it starts from aluminum all the way down to diba, hindi ko kabisado periodic table. Hindi naman kasi kinakabisado to. From aluminum to astatine. Okay? So ganun. Huwag niyo kakabisaduhin periodic table. Kaya nga naka-table yan eh. Okay? Ako, chemist ako. Di ko kabisado yan. Familiar lang dapat. Okay? So, ganun. So, again, expanded octet, this applies when your central atom, again, central atom, is third period pababa. Okay? So, ano po gagawin ko dito? So, we will modify the NASU rule. Diba kanina, needed, available, shared, unshared. No? Since we know that the central atom can contain more than 8 electrons, tatanggalin na natin yung N. Tatanggalin mo na yung needed. So, ang gagawin mo is that magiging ASU na lang siya. No? Magiging ASU. Hindi na siya NASU rule. ASU rule na yan. No? Okay? Legit yan. Hindi yan joke. No? So, gagawin mo na lang yung ASU rule. Paano ko sasagutan yan? Kuha tayong example. Kunwari, we have sulfur hexafluoride, SF6. Hindi na tayo nasurula, asurul na. Okay. So, paano ko malalaman kapag mag-aasurul ako or nasurul? Okay. So, check mo muna. So, sulfur ang aking central atom. And sulfur is in third period. No? Sa baba siya ni oxygen. So, pwede akong mag-asurul dito. And also take note that may 6 akong terminal atoms. No? Kapag 4 yan, pwede pa yung nasurul dito. So, pag 4 yung terminal atoms mo around your central atom, pwede pa yung nasu. Pero, pag ganito na yung case, pag lagpas na sa 4, kunwari 5 or 6 na yan, asurul na lang. Okay? Kasi for example, may SO2. SO2, pwede mo gamitin yung nasu dyan. Okay? Pero whenever your terminal atom exceeds 4, no? Kunwari 5 na yan or 6 such as in this case, yan ay ASO rule na. Okay? So gawin natin yung ASO rule. I don't know if rinig masyado yung ASO sa baba, no? So gawin natin yung ASO rule. Available, shared, unshared, no? Available, ano yan? Valence electrons. Sulfur is 6 kasi nasa group 6 siya. Fluorine is 7 kasi nasa group 7 siya. Times 6. 7 times 6, 7, 14, 21, 28, 35, 42. 42 plus 6 is 40, 48. Okay? Paano na yung S, sir? Diba, ang formula ko sa S ay N minus A. Sa ganito, hindi ganun gagawin mo. Okay? So, ganito po gagawin nyo. Hindi kayo mag-N minus A. Instead, ganito. So, i-draw mo sa gitna yung central atom. Then, yung terminal atoms, ipalibot mo sa central. Ipalibot mo yung anim na yan sa paligid niya. Okay? So, lagay mo yung anim na terminal atoms. And then, you connect your terminal atoms with a single bond to the central atom. So, mag-connect ka ng single bond to the central atom. Okay? So, ganun. I-connect mo sila. Ano sunod? Ang susunod ay, yan, bilangin mo how many single bonds ang ginamit mo. So, I use 6 single bonds. No? So, 6 single bonds is equivalent to 12 electrons. So, yun yung shared electrons mo. Okay? So, ganun na. Wala nang N-A. So, ang gagawin nyo muna, you connect the terminal atoms with a single bond to the central atom. Then, saka mo bilangin how many electrons yung shared. Okay? So, in our case, we have 6 bonds. So, ibig sabihin 12 electrons ang shared. And then, lastly, for unshared, that is A minus S pa rin. No? So, that's still A minus S. So that's 48 minus 12. That will be 36 electrons, or ilang lone pairs to? 18 lone pairs. No? So you're going to distribute the 18 lone pairs na. Let's start with the terminal atoms. This fluorine requires 8 electrons. No? Kasi octet rule yung fluorine eh. Hindi naman yan sulfur. No? So, kasi nasa group 2 din yung fluorine. Okay? So yung terminal atoms, always octet rule yan. Except for hydrogen. So yan, terminal yan. So octet rule yan. So may dalawa na. Kailangan mo pa ng 6 in the form of 3 lone pairs. Okay? So for the other fluorine atoms, the same logic is true, no? So yung mga fluorine atoms na to, tig-single bond sila with the central atom. So that means kulang pa sila ng tiga-6 na electrons or 3 lone pairs. So I'm going to distribute all the terminal atoms with 3 lone pairs. No? Lalagay ako ng 3 lone pairs dito, 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 and dito. Pati ito. Okay, so ayan. So tigtatatlo na lone pair for each terminal atom so that all of them will follow the octet rule. Ano yung hindi sumunod sa octet rule dito? Yung central atom. Kasi 12 electron meron siya sa paligid niya. But it doesn't matter. Okay, so it doesn't matter. Kasi violation nga siya ng octet rule eh. Okay na yan. Tanggapin nyo na lang siya. So this is the structure for SF6. No? So again, ano yung gagawin mo muna pag ganito yung case? So you check kung ilang atoms na sa paligid niya. Okay? So tignan mo ilang atoms na sa paligid niya. Kapag 4, pwede pa yung nasu. Pero kapag 5, 6 na yan, asu na yan. Asu rule. Okay? So anong gagawin mo kapag asu rule? Bilangan mo yung available. Then sumunod, before you count the S, you draw the skeleton muna. Nasa gitna yung central atom. Nasa paligid yung terminal atoms. Lahat na ng 6. Then you draw single lines to connect them. Tapos bilangin mo how many bonds ang ginamit to connect all the terminal atoms to the central atom. That will be your shared electrons. And then yung unshared, ganun pa rin. Nothing changed. No? So A minus S equals unshared. No? Divided by 2, you will get the lone pairs. Again, distribute the lone pairs on the terminal atom before the central. Okay? So that will be the 3 violations or 3 exemptions to the octet rule. Now let's try some few examples here. Let's have number 1. Draw the Lewis structure for aluminum iodide, no? Aluminum triiodide. So ano yan? Is that a violation of the octet rule? Anyone? Pwede mag-pitch in ng idea? Violation ba siya ng octet rule or not? Yan ay violation. Ako na rin sumagot. Bakit? Kasi aluminum yan eh. Nasa group 3 yan. Di ba sabi ko, pag ang central atom, nasa group 2, nasa group 3, violation agad yun ng octet rule. Okay. So why is aluminum the central atom? Because iodine is terminal atom. Okay? Siya yung mas mataas yung electronegativity. So siya yung terminal atom. So in order for us to draw aluminum triiodide, so since this is a violation of the octet rule, ang gagawin ko, ano to, incomplete octet yan. No? So kapag ganun yung case ko, I will just draw their Lewis symbol and I will connect the dots. So yan. Ganun lang yung sagot dito. Draw the Lewis symbol, connect the dots. Kasi siya ay nagfo-fall under incomplete octet category. So you just draw single lines. Okay. So the final structure is Al with 3 iodines around it. So yan na yan. Okay. Ayan, they're done. About BEF2. Ito, anyone. This is a violation of the octet rule. Pero, alin sa tatlo? Incomplete octet, odd electron rule, expanded octet. Anyone may pitch in your ideas. So, incomplete octet to. Bakit? Kasi we're talking about beryllium as the central atom. Fluorine will be the terminal atom. So, this is the most electronegative atom. So, beryllium will be the central. Okay? So, since beryllium is the central atom, at nasa group 2 siya, incomplete octet yon. So, paano ko ito draw yon? You just draw its Lewis symbol. Its Lewis dot symbol. And then you connect the dots. Ganun lang. Ganun lang siya kadali gawin. Di ba? Sana all incomplete octet na. Kaso hindi eh. Okay, so yan na yun. Yan na yung structure niya. Let's have this one. Last one. After na to, proceed tayo with molecular geometry para tapos na. And feeling ko hindi pa natin matatapos yan. Okay. So, let's do number 3. Draw the Lewis structure for phosphorus pentafluoride. Okay. Phosphorus pentafluoride, PF5. Okay. So, any ideas? Violation to ng octet rule, but alin doon? Okay. So, pwedeng add electron. Sa group 5 siya. Pwede ring expanded. Okay. So, dalawa yung case natin. It could be odd electron, pwede siyang expanded. No? Okay, so okay lang naman na ganun. Kasi never to magiging incomplete octet. No? So, it could either be odd electron or expanded. No? Okay. Pero, ganito. Ang aking ang aking shortcut sa isip, no? Kapag add electron, it always involve nitrogen atoms. Puro nitrogen lang talaga yung mga radicals usually. So, ganun. So, most likely this will fall under expanded octet. Okay. So, aning ways ko to deduce kung anong type ng violation to. Okay. So, alamin mo, anong group number yan? So, group 5 yan. So, pwedeng add electron yan. Then, nasa third period din siya. Pwede yung expanded, no? Pero, commonly, yung nagko-commit ng, odd electron ay si nitrogen. And then also, by looking at the subscript of your terminal atom, lagpas yan sa 4, no? So, most likely, ito ay expanded. Okay? Most likely. Okay? So, with that being said, no? So, ito, since 5 yan, expanded yan, no? So, let's do the ASU rule. ASU. Ano nangyari? Let's do the ASU rule. ASU PF. Available phosphorus that is in group 5, fluorine that is in group 7 times 5, 7, 14, 21, 28, 35 plus 5, 40. Okay, so 40 electrons. How about the shared? Sabi ko, draw mo muna yan. And then you draw the terminal atoms around the central. Yung limang yan. Then you connect them singly. Okay? You connect them with a single line. So, ilan na gamit natin? 5 lines, no? 5 bonds or 10 electrons in total. And then unshared, that is A minus S. That will be 40 minus 10. And that's 30 electrons or divided by 2, 15 lone pairs. So, I have to distribute 15 lone pairs to my terminal atoms, no? Kunwari, na-distribute mo na sa terminal atom yung mga lone pair, tas may sobra pa, sa central atom mo siya i-distribute. Okay? So, yan. Let's do this na. Okay, 15 lone pair. Let's look at this fluorine. So, may 2 electrons na yan. Okay, so may 2 electrons yan. Anong gagawin natin sa 2 electrons? Kailangan niya ng 3 pang lone pairs or 6 electrons na. Okay, so maglalagay ako ng 3 lone pair or 6 electrons for it to follow octet. So gawin natin yan sa iba din. Gawin natin sa iba pa. Okay? Kasi pare-parehas lang naman yung fluorine atoms na yan. Bilangin natin kung 15 na ba yung lone pairs na nagamit natin. Bilangin natin. No? So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so 15 lone pairs ang nagamit natin. So, the structure of PF5 is yan. Okay, so phosphorus yan na may 5 fluorine around it. So, para siyang si Patrick Star. Okay, wherein yung ends niya ay phosphorus. Okay, so yan. Maybe today, di natin discuss na lang muna yung molecular geometry, no? Kasi kapag diniscuss ko yun agad, baka mamaya matabunan naman itong diniscuss natin na expansions. I mean, violations ng octet rule, no? So for now, i-wrap up na natin to. Maaga tayo magdi-dismiss. Pero, may gagawin kaya, no? So, with the idea on how to draw the Lewis structures, you can actually answer the ano yun? Teka lang, buksan ko yung canvas. Pwede nyo na mabuksan yung lab experiment 3. Buksan ko lang yung canvas, ha? So you can actually start doing that na. So yun muna gawin nyo. Since medyo short, meron kayong 1 day na pahinga because of the holiday on Thursday. That's the anniversary of the People's Initiative, no? People Power. Okay. So ito, teka lang. Ito, experiment 3 guide questions. Buksan ko lang, ha? Medyo mabagal lang net ko. Tapos sabihin ko sa inyo paano nyo sasagutan to. Okay, so yan. Nabuksan ko na yung Nabuksan ko na yung file. Let me share it dito. So, yun, share ko lang dito. Ano yung task nyo, no? Pakisabi na lang sa mga absent ulit, no? Pansin ko tayo na lang yung yung mga nandito, no? Pero okay lang, no? Hindi natin alam ginagawa ng iba. That's fine. Okay, so anyway, so yan. So we will end until the expanded octet lang kasi that is enough for you to be able to draw the molecules here. So I want you to draw the molecules here, no? Then by Friday, ko-continue tayo with the geometry, okay? Para hindi matabunan yung yung mind nyo sa ano nga pala yung mga pinagsasabi ni sir, ano yung ASO rule, no? So para hindi kayo matabunan sa molecular geometry, practicein nyo na yung pag-drawing ng molecules, okay? So you can actually start answering itong part na to. Yung first column lang nito, ano po gagawin nyo dito? Picturean nyo na lang. Okay. So, document file naman yan. So, edit nyo na lang. You take a photo of the molecule. Huwag nyo i-google. Okay lang mag-google kapag confirmation. Pero yung drawing, kayo na mismo gagawa. May google nyo na lang lahat yan. Alam ko naman ginugoogle nyo lang tong part na to, no? Okay. So, pero yung drawing, kayo na yan, ha? Okay. Kaya nyo yan. Okay. Is itong mga guide questions, pwede nyo na rin sagutan yun. Okay? So, itong part na to, guide questions. So, itong column, first column, pwede na kayo magsagot. Practicein nyo na yung incomplete octet, odd electron, yung expanded octet, or yung usual NASA rule. Okay? Mag-ano tayo? Mental checking. No? Check natin mentally kung anong type ng Lewis structure magagawa natin. So, ano yung way ko para mabilis ako mag-draw ng molecule? Paano ko malalaman kung sino agad yung gagamitin ko? Ganito lang. I check first whether my atoms are in the first and the second period ng periodic table. For example, HCOO. Okay, so, since HCOO yan, first and second period yan, so yan ay usual octet rule. Okay? CO2, nasa first period yan, nasa second period yan periodic table, so you do the usual NASA rule. BF3, boron will be the central atom, nasa group 3 yan, so this is incomplete octet. Okay, so mabilis ko lang malaman kung ano gagamitin ko. CHCl3, so except for chlorine, carbon and hydrogen are on the first and the second period, no? Okay, so yung chlorine, okay lang yan, terminal atom yan eh. So it doesn't matter kung nasan siya. Basta yung central atom, yun yung tignan mo, asang period siya or anong group number siya. Okay? So ito, carbon and hydrogen is in group 1, group 2. Okay? So chlorine, M lang yan kasi ano yan, terminal yan. So this will use the usual NASA rule. CCl4, usual NASA rule yan because the central atom is carbon and it is in the second group. H3O+. Okay, so for H3O+, ito ay hydronium ion. So I will tell you na oxygen will be the central atom here. No? You can do the usual NASA rule as well dito. Okay, so oxygen will be the central atom. Why? Kasi sabi natin, yung pinaka-terminal atoms talaga sa lahat will be hydrogen, followed by oxygen or halogens. Okay? In this case, yung hydrogen, single bonds lang kaya gawin yan eh. So, no choice. Si oxygen yung mag-multiple bonds. So, yan. Usual NASA rule yan. PF5. So, phosphorus will be the central atom. Phosphorus is in group 5 and also it is in group, it is in period 3, you know. So, with those information, it could either fall sa odd electron or sa expanded octet. But I told you earlier, nitrogen usually does the odd electron rule. So that means ito ay expanded octet. Ganun yung mga naiisip ko pag nakikita ko molecules, no? And tinitignan mo siya, tapos may mga numbers na lumalabas sa utak mo. Mga NASA rule lumalabas, no? Okay. Xe, xenon, obviously, odd electron rule. Obviously, that's expanded octet. Okay. Whenever you see a noble gas, pag may noble gas ka na central atom, yun ay expanded octet. Okay. Ito siguro question nyo, sir, bakit kaya ganun? Ako lang naman nagtatanong. Okay. Kasi 'di ba sabi natin, the atoms want to be a noble gas configuration, kaya stable sila. They do not react that much. How about xenon? The problem with xenon is that it is way too far, no? I mean, yung electrons niya ay way too far to the nucleus. So that means mahina na yung effect ng nucleus sa electrons outside. We call it the effective nuclear charge. Hopefully, na-discuss yan sa lecture niya, yung effective nuclear charge. Kasi kapag malaki na yung atom masyado, the electrons outside aren't affected that much by the nucleus. No? So, humihina na yung nuclear charge pag malaki na yung atom. So, that's why xenon can react. No? Yung valence electrons niya, pwede na siya makialam with other atoms. Okay. However, other noble gases, maliit pa yung mga atom na yon, so that kapit na kapit sila sa nucleus. Pag hindi na sila makapit sa nucleus, dun lang sila nagre-react. Okay? Okay, so usapang effective nuclear charge yun. Okay, so this is expanded octet. PO4, -3. The central atom would be phosphorus, group 5 yan, and nasa period 3. So, ano yan? Either add or expanded. The answer is expanded. Kasi kapag add, usually nitrogen yung gumagawa nun. SF4, ito. Ito yung trick. 4 yung terminal atoms. So, pwedeng usual nasa rule yan. But your central atom is sulfur. It is in the 3rd period. So, anong gagawin mo? Ganito yung ginagawa ko kapag contradicting na yung mga ideas, no? Maaari, ito, 4 na terminal atom yan. Baka pwede yung nasa rule dyan. Okay? Possible. Pero, ganito. If you write the NASU rule for SF4, it will fail. Kapag fail yung NASU rule, punta kayo agad sa ASU rule. Okay? Punta agad kayo sa ASU. No? So, ganun lang. Okay, so ganun lang. Pero to be honest with you, sa ilang years ko na kasi na pamumuhay, sa 23 years ko ng pamumuhay sa mundo, itong mga molecules na to, I encountered them a lot. No? So, kaya alam ko na yung mga pwede isagot. No? Kaya alam ko na, ganito yan. Okay? So, alam ko na yung structure nila. Pero, you can start developing the intuition kung ano yung itsura ng molecules by just remembering the rules ng NASO rule. Okay? So, basta alam niyo yung rules ng NASO rule, yung sa resonance, and then yung sa expanded octet, you can answer all these items very quickly. And hopefully sa quiz ay ma-ace nyo. Okay? So, yun na lang muna gawin nyo, no? Until mag-meet ulit tayo by Friday. So, on Friday, we will discuss molecular geometries, no? Pwede sagutan nyo na rin to, no? Kasi baka mamaya matambakan naman kayo ng gagawin, no? Remember, malapit na tayo mag-midterms, no? Medyo marami na kayong gagawin sa ibang subject. So, tayo, chill-chill lang. Experiment lang pati yung quiz, no? So, chill pa rin yan. Okay? So, yan. Bago kayo matambakan, unahan nyo na, no? Sagutan nyo na yun. Why are double bonds, triple bonds shorter than single bond? May sagot doon later. Sa molecular geometry, didiscuss natin. Ay, teka lang. Basahin ko lang guide questions, ito. Ang masasagutan nyo pa lang dito sa guide question ay yung number 4. Electronegativity lang yan. Number 4. Number 5. Sinabi ko yung sagot dyan kanina. Review nyo na lang yung video mamaya sa YouTube. Ayan, so yung 4 and 5, pwede nyo na sagutan. Pero yung 1, 2, and 3, sa Friday nyo pa yung masasagutan. Doon ko sasabihin yung sagot. Okay? So, ganun lang. Okay? With that, no? So, we are done for our today's session. Hopefully, nadagdagan na naman ang kaalaman nyo. Sana. No? Okay, so hopefully, makatulong yung mga tips na sinabi ko sa inyo on answering this problem. Okay? If you have any question with regards to this, to our activities, no, just let me know. Okay? So, by next meeting, Friday, mag-aano tayo, molecular geometry. So, I actually have my molecular models na. Medyo excited ako to gamitin, pero sagot na lang muna kayo. Practice pa kayo ng, NASU rule and the violations sa Octet. Okay? So, ganun lang. Practice makes perfect. But nobody's perfect. Still practice. No? Wala tayong magagawa. Okay. So, yun lang. So, I'll see you again on Friday. I hope na sa Thursday, sagot-sagot kayo ng activities, no? Especially yung mga drawings, okay? So, a copy of this video will be uploaded mamaya on YouTube, no? So, I'll see you again, no? At teka lang, may question. First column lang po ba sasagutan? Yes pa. First column lang muna. Kasi yung drawing lang yan eh. Again, dito sa first column, gagawin nyo po is picturean nyo yung answer. Okay. So, dun sa picturean nyo lang. Okay? Malinaw lang. Wag nyo i-google ha. Mamaya, kinopy-paste nyo lang sa Google yan. Minus 100 yan, no? 100 ligtas points. Babawasan pa kayo ng ligtas points. Ano na lang, picturean nyo na lang yung drawing nyo. Word file naman to, so you can upload your pictures dito. Okay? Wag mag-google ha. Okay. Pwede gamitin yung Google for checking, pero kaya nyo yan, no? Kaya nyo yan. Okay? So, first column lang for the first part. On the guide questions, answer items 4 and 5 for the meanwhile. Okay? Any questions from the class? No? Or okay na tayo? Maaga tayo mamamahinga ngayon. Okay, so sige. So without any questions, I'll see you again next meeting. So kita-kits sa Friday. Okay? Hopefully makapag-review kayo. Okay, so bye-bye, and I will upload a copy of this video mamaya, no? So that your classmates na wala ngayon dito, pwede nila mapanood. So I'll see you again. Bye-bye, and stay safe as always.